So now that you've been given a high-level overview of this particular ImageStreamGang app case study, let's talk about how completable futures are going to be applied here to the app to do all the work. So we're going to focus on the process stream method. That's the callback hook that's part of the StreamGang framework. We've talked about that before. And the particular implementation we're going to look at here is known as ImageStreamCompletableFuture1.java. And that kind of gives away what will come later if we have time today, which is there's also an ImageStreamCompletableFuture2 implementation, which shows off a bunch of other cool features. And here's roughly how this works at a high level. So we start out by getting a list of URLs that the user has provided as input. So we get back a list of URLs. And then we go ahead and do a sequential stream that's combined with completable futures. So this is this wonderful combination of things. And this really gives us a very nice variant of reactive programming. Not quite as integrated and quite as cool as reactive streams, but it's close enough for rock and roll. So what you're going to see we're going to do here is we're first going to convert the list of URLs into a stream of URLs. Now we have a stream of URLs. And then we're going to go ahead and use the intermediate operation map in conjunction with a behavior we'll talk about to asynchronously check to see if the images have already been cached locally. And at this point, the implementation varies wildly from the parallel streams version that we looked at before. So this is about as far away as you can get while still using sequential streams. And one of the things that makes this quite different is the very interesting use of optionals. And you'll see how they get used and why they get used in a second. So this map operation, this intermediate operation, converts a stream of URLs to a stream of completable futures to optional URLs. Why the heck do we have a stream of completable futures to optional URLs? What on earth is going on? Well, I'll explain that when we get into the details a little bit more. But the long and the short of it is, when we go to check to see whether or not there is already a cached version of this, we need to be able to do something that will allow us to be able to differentiate between images that have already been downloaded and images that have not yet been downloaded. So for the images that have been downloaded, we want to ignore them because we're not going to duplicate existing work. But if the images have not been downloaded, then we actually want to download them. And so we're going to use an optional to differentiate this. And it's super, super, super cool. But it makes the code a little bit more complicated. So what we get at this point is we got a stream of completable futures to optionals to URLs. And then we go ahead and we take that stream and we apply the map intermediate operation again. And this time we pass in the download image async behavior. And what download image async does is it converts the URL completable futures for images that have not already been downloaded. So the ones that we've not seen yet. We're going to go ahead and start to download them asynchronously. So we're going to download those things asynchronously. And what we're going to get back there is going to be a stream of completable futures to optional images because those images are being downloaded now and we want to make sure they download before we do anything further to them. And we use optional once again because we have to be able to differentiate all the way through the stream between URLs that have already been downloaded, which we want to ignore, and URLs that are in the process of being downloaded because they weren't there already. So what we do now is we end up using flat map to go ahead and take we have a stream of completable futures to optional images that are being downloaded. And as those images complete, the ones that are not empty, there's the ones that we're actually downloading complete, then what we want to do is we want to asynchronously apply all of our image filters to them. And that's going to end up expanding the number of elements in the output stream. So let's say, just for sake of argument, we're going to download 100 images, and we've got 3 filters to transform each of those images. So we're then going to end up with 300 completable futures to the images that are being filtered and transformed, because it'll go up. So that's why we use flat map, because the number of elements in the output stream will be n times bigger than the number of elements in the input stream because we applied n filters to each element. And of course, this is all going to take place asynchronously as well. And we'll end up basically with a stream of completable futures to optional images that are being transformed and stored asynchronously. And then the last thing we're going to do here is we're going to use our stream of futures collector to collect that gigantic stream of completable futures to optional images that are being downloaded, transformed, and stored. All the stuff that's happening there. We're going to give one completable future that will wait for all that asynchrony to finish. And we've seen that before. That was what we talked about last time in the context of the futures collector IntStream and a couple other variants of that and so on. And then what we do is we use a completion stage method from completable futures that says, after all those things are done processing asynchronously, go ahead and basically log the results, which in this case is just going to go ahead and say how many images were downloaded. And the very, very last thing we're going to do here, because we don't want the program to fall off the end of main, is we're going to call join. And join is the one and only call in this implementation strategy. So you can see what it's doing is it's basically waiting for everything else to finish. And remember the discussions we've had before, you want to use join as sparingly as possible, because anytime you join, you're waiting, you're blocking. And we don't want to block things unless we absolutely have to. And here's where we absolutely have to. You don't normally want to use join. Instead, you want to use other completion stage methods like then compose or then apply or whatever to avoid blocking. But this is a case where we have to block, because otherwise it'll fall off the end of main and we'll get no output at all, which is not what we want. Okay, so that's the end of the kind of high-level walkthrough of the flow through the program. And again, what I want you to sort of marvel at here is the way that we're using the sequential stream to structure the flow of control. So we say, asynchronously check to see if we've already downloaded the images. If they have not been downloaded, asynchronously download them, then asynchronously apply the filters, and then collect all the results of all the asynchronous stuff that's done. And when that's finished, kind of print out the number of things that we dealt with. So that's the flow. That's what we get from using a sequential stream. We get the flow of the control. What we get from the completable futures is all the asynchrony stuff that's happening kind of behind the scenes. And it's the magic of really collect and the stream of futures collector that's going to make all this stuff work in such a clean, nice, orderly way, well-structured way. Okay, so that's the end of the overview of that part.